Hi everyone, I'm Michael and I'm back with another video. In today's video, I'm going to be walking you guys through this full insurance management system that I built using FastAPI, PostgreSQL, and React. The system is integrated end to end, and it also supports live database updates. I decided to build this project mainly because I noticed a lot of the portfolio projects that are being built today, they use mock data. So I just decided to build something that is a bit more realistic and something that is closer to what you would actually see inside a company environment. And also, I've been learning a lot about databases, uh, front-end development, and back-end architecture over the past couple of years. So this project was my way of bringing them all together and building one cohesive system. So with that being said, let's just jump right into the video. Alright, so before I dive into the walkthrough, I want to quickly show you guys how the project is structured. So the backend lives inside this main directory right here. It runs using a FastAPI and it runs on port 8000. But the front end is a separate React application and it runs on its own development server. But both connect to the Postgre database running locally. So to start everything, I'll first launch the backend using Unicorn. I'll just open up my terminal. I'll provide you recording. See the backend being served at this address right here, the one that ends with 8000. So once that finishes launching, we'll just go ahead and open up another terminal for our front end. And for our front end, just need to go to the directory on which our entry point exists for the front end. So I'll just copy this. And npm. You see now our front end has launched at this address right here. If you just slightly hover over it, it should give you a follow link, or you could just click it itself. And once you click on it, we'll just launch the user interface or the UI of the project. So this is what it looks like. Now let's get into the details. Alright, so now that the application is running and we're looking at the interface, it's important to understand that everything you see here isn't just a random data. There's actually structure inside of it. So before we go deeper into the UI, let me just show you guys how the system is modeled at the database level. Let me just show you the ERD I created. So this is the ERD I created before building the schema itself. So it basically maps out how everything connects. So one account can have multiple policies, and each policy can have multiple claims, and each claim can have multiple claim payments. And it might sound obvious when you say it out loud, but if you don't design it correctly from like the very beginning, things might break later. And this is where normalization comes in. So it's really just about organizing data in a way that avoids duplication and keeps relationships clean. And from this ERD diagram, I was able to translate everything into Postgre tables using UUIDs and foreign key constraints. So for example, you literally cannot create a claim. Let's scroll. Claim section. Yeah, so you literally cannot create a claim without a policy being attached to it. So the database enforces that for you. So it's just not a constraint that exists within the front end, but like the database enforces that for you as well. So it's important because this means integrity of the system isn't just handled inside the front end, but it's also enforced inside the data layer as well. Now that we've seen how the database is structured underneath, let's look at how the user interface receives the data. So let's start off with the backend. So this is the backend, and this layer is built using FastAPI. and it acts as the bridge between the database and the user interface. So the front end doesn't directly talk to the Postgres database, which I just showed you, but instead it makes requests to one of these endpoints. So let's look at the claims endpoint as an example. Claims will be easier than policies. Try it out. So when I click on execute, what's happening behind the scenes is that the API is running SQL queries, including joins, to combine data from claims, policies, and accounts. So instead of just returning IDs, it will return meaningful information like account names, policy types, and claim details in one structured response. So if you look at this JSON response, this is live data coming directly from the PostgreSQL. So there is no mock data here anymore. This is just a real data set that powers the application. So, and this separation is important because the database enforces the relationships and the integrity, and the backend handles the querying and the logic. The front end simply consumes and displays the structured data in a more user-friendly approach. So, if you look at the claim number of the first account, and I go back to the UI and open claims section, you'll see the same record being displayed. So CLM 048, CLM 048. So it's just in a more user-friendly format. So what we're seeing here visually in the browser is just directly tied to what the API just returned. All right, so now let's do something that actually proves the system is integrated from end to end. So far, we've been reading data directly from the database, which is great. But now let's actually create a data live and watch it go through the entire stack. So I'll go to the backend first. So out of all these endpoints, the endpoint that allows us to insert data directly into the database is the post accounts endpoint. So here I'll click on it and click try it out. So this is the format, the JSON body format that allows us to insert a row directly to the database. This is just the general format, so I'll remove this. I already have a specific or like a unique like formatted JSON copied to my clipboard because I figured just typing it out while recording will take some time. So you can see here the name is demo for YouTube. I was testing it out a couple of times before I actually hit the start recording. So I'll just modify this or modify a couple of its attributes. And I'll name this demo for Zoom. Account number, ACC, change to ABC. Business should be good. The email should be, we'll change to Zoom. Zoom, phone number, 565 line 1 723. Address 2 should be good. The city, Toronto, Ontario, just change the postal code and we should be good. Alright, so once we're done, I'll just click on execute. Now you can see the response body right here returns the full object, including the generated returns, the UUID and the timestamp. So the UUID, the timestamp, and the UUID was created by Postgres itself. Now let's just verify that it exists in the database. So I'll just open up pgadmin. Alright, so now I'm going to run a quick select query directly against the accounts table, just to prove that the record wasn't just created somewhere inside the API layer, but it also exists inside the database. So I'll just go ahead. So let's the account number, its legal name, its status, and when it was created. Account where its legal name equals, we named it demo for Zoom. Now, once I'm done, I'll just click on execute. Name, made a typo. And there you go. So it's the same record sitting directly inside PostgreSQL with a generated UUID and a creation timestamp, as you can see right here. So what happened? Was we created a data through the API. It was written inside the the PostgreSQL. And now to just fully complete the loop, or like the stack, let's just go ahead and verify that it exists inside the user interface. So I just go here. So this is the accounts tab. I'll just go ahead and click on refresh. So we're trying to get an account that says demo for Zoom. So as you can see, I've run a couple of tests before I recorded this video. So the first and the second say demo for YouTube, but now our records should our records account name should say demo for Zoom. So I'll just refresh. Click on refresh. See, so there it is. So demo for Zoom. So this basically proves that the database, the full flow, which is the database to FastAPI to React and back to the database, is consistent. So this isn't just mock data. This isn't just a static JSON that I'm using, but it's a fully integrated system with live operations. And that's really that's really the difference between building a front end and building an actual production style system. And that pretty much wraps up the entire project. At its core, it's an internal insurance employee portal, but the main focus wasn't just building a clean interface, which you see here, but it was building or designing a properly structured database, managing that database with SQL, and then exposing that data through FastAPI and presenting it on the user interface. So the UI itself, I built it using Figma, and we could just look into some of the tabs it has and some of the features that it supports. So let's start off with the dashboard. So the dashboard keeps track of the active accounts. Displays the active accounts, the open claims, the ones that are in review, total premiums. It also generates some graphs. So claims by activity generates a pie chart based on the severity of the claims. Financial exposure, I think, was based on provinces, and portfolio summary is just an overall summary of the accounts that exist. So total accounts, open claims, ones that are in review, and total premium. So the accounts tab, so it keeps track of the active accounts, total accounts, and active ones. It also supports some searching options and filtering options. Next is the policies. The policy is very similar to accounts as well. So total policies, the active ones, the ones that are expiring soon, the total premium. It also supports searching and filtering. It also has searching and filtering options. Next is the claims. Again, very similar to accounts and policies. So it displays total claims, the ones that are in review, the ones that are approved, and total claims, or the average claim amounts. This also has searching and filtering options. And lastly, we got the reports. So the reports actually pulls metrics from the database and makes up some graphs from those metrics. So it has claims overview, charts for claims overview, charts for premium analysis, let's see, for risk assessment, and finally, it also generates a chart for performance metrics. Alright, so that's pretty much it for today's video. I hope you guys enjoyed it. I'll be leaving links to some of the tools that I used in the description. I'll also be pushing this project onto on GitHub, so you guys can just explore the code, run it yourself, and just build on top of it however you like. And I'll catch you guys with another video showcasing a different project.